Hello, my name is Paul-Gauthier. I'm from Avignon University. I will present to you in this video our work called Hiding Speakers' Sex in Speech using Zero Evidence Speaker Representation in an Analysis Synthesis Pipeline. So this is a work we have done when I was visiting Yamagishi Sensei Lab at the National Institute of Informatics as a part of the Voice Personae project. So I will first quickly introduce the context of this work. So we are interested in attribute privacy, where instead of hiding the full identity of the speaker, we want to hide only one characteristic, one personal attribute of the speaker. So this can be, for instance, the sex or the native language. This is also known as user configurable privacy. And since we hide only a part of the speaker-related information, we can expect to find a better trade-off between the utility and the desired privacy. Here we focus on the sex-related information. The attacker's knowledge about the attribute can be represented by a probability distribution over the set of possible values for the attributes. And Shannon defines the concept of perfect secrecy, which can be applied to privacy, where we want the posterior probabilities to be equal to the prior probabilities. So this means that the attacker's knowledge does not change when he or she observed new data. When the attribute is binary, like for the sex, this is reached when the log likelihood ratio is equal to 0. This is why we also refer to zero evidence or zero log likelihood ratio. In the previous work, we proposed a discriminant analysis-based approach that aims in setting the LLR to 0. It is based on normalizing flow, where you map the data into a base space, where the first component is the log likelihood ratio. This component can be set to 0 for privacy, and the data can be mapped back into the original feature space. So this has been applied on the concealment of the speaker's sex information into DNN speaker embeddings. So then we were wondering, can we use this kind of protected speaker embeddings for voice conversion? So now I will present to you our new work. So it is based on analysis synthesis. So you have a first step of feature extraction from the speech. From these features, you can resynthesize the speech using a vocoder. Here we use HiFiGAN. We have three types of features: the F0 trajectory extracting using YAPT, a content representation extracted using a UBERT-based content encoder, and the speaker embeddings extracting using ECAPA-TDNN. Here we assume the content representation to not contain any information about the sex of the speaker. And we apply transformation only on the F0 trajectory and on the speaker embeddings. For the F0, we apply an affine transformation. And for the speaker embeddings, we apply the discriminant zero LLR based protection that we proposed in the previous paper. We assess the protection ability of our systems in terms of automatic sex classifier results. So we train an automatic sex classifier on protected row speech, and we report its results in terms of equal error rate and DECE, which can be seen as the expected amount of sensitive information disclosed by the score. We also want to check if the protected speech can still be used. So we report the automatic speech recognition performance in terms of word error rate, This will also inform us if the linguistic content and the intelligibility has not been altered too much. We also report the automatic speaker verification results in terms of equal error rate and CLLR mean. And we also report some listening test results. For the protection assessment, here are the results of the automatic sex classifier. We can see with the last line that with our approach, the equal error rate is higher and the DECE is lower. So this suggests that with our approach, the automatic sex classifier has more difficulties to extract useful information from the speech. In terms of automatic speech recognition, we can see that the word error rate does not increase too much. However, for the automatic speaker verification performance, we have here a significant drop of performance. So this might be due to the fact that the sex information definitely helps in separate the speakers, or this might also be due to some kind of domain shift introduced by the voice conversion system. We also asked 19 listeners to assess the naturalness of the protected speech. We can see that the naturalness is quite stable along the different systems. And we also asked the listener whether the speech sounds like a female or a male or in between. And here we have the corresponding scores. We can see that with our approach, the distributions for the male in blue and the distribution for the female, female in blue and the distribution for the male in orange overlapped. So this suggests that the human can hardly distinguish between speech coming from male and speech coming from female using our approach. So to summarize, we propose to reduce the speaker's sex-related information in speech utterances by applying an affine transformation on the F0 trajectory and by applying the zero LLR discriminant analysis-based protection on the speaker embeddings. We assess the protection ability of our approach in terms of automatic sex recognition performance, but also in terms of listening tests. Thanks for watching the video. You can have a look to our paper, but also to the code and some audio examples that you can find with this link. And if you are coming to Greece, it will be a great pleasure to meet you in front of my poster. Thank you.